All right, today we're going to demystify big data. We're going to get into the tech that really runs our digital lives, from the original giant, Hadoop, all the way to the super fast systems we use now, like Cassandra. But to really get where we are now, we first got to understand the problem they were all built to solve in the first place.
I mean, really think about that for a second. You finish a show and boom, instantly there's a whole new list of recommendations that feels like it was made just for you. How in the world does a company like Netflix pull that off for over 200 million people, all at once, without the whole thing just crashing? Well, the answer is all about how they solve a massive, massive problem.
And that right there is what this is all about. This isn't just a Netflix thing either. It's a challenge that pretty much every major company in the world is dealing with. They're all wrestling with this concept we call big data. So, before we can even talk about the solutions, you gotta understand just how huge this problem really is. It's usually broken down into three main characteristics, what everyone in the industry calls the 3 Vs.
First up, we have volume. And look, we're not talking about a big spreadsheet. We are talking about a scale of data that is almost impossible to wrap your head around. Take Facebook, for example. They process over 4 petabytes of new data every single day. That's 4,000 trillion bytes. The sheer size alone makes it totally impossible to store or analyze on just one computer. Next up, velocity. This data isn't just big, it is incredibly fast. Just think about the constant fire hose of tweets or stock market trades or all the sensor data coming from a smart car. We've gone from processing data in batches overnight to needing answers in real time, right now. Uber, for instance, has to tweak its pricing based on ride requests and where drivers are, and that changes every single second. And finally, there's variety. Data doesn't just come in neat rows and columns anymore, not by a long shot. It's all sorts of messy. Unstructured text from your emails, photos on Instagram, YouTube videos, semi-structured stuff like JSON files. In fact, something like 80 to 90% of a company's data is totally unstructured. So what does all this add up to? Well, it's pretty simple, really. You take that immense volume, that incredible velocity, and that complex variety, and you smush them all together, and they just broke traditional databases. They just weren't built for this new reality. A totally new way of thinking was needed. And that's where our first hero of the story comes in, Hadoop. Inspired by some papers that came out of Google, Hadoop was created to attack this big data problem head-on by completely rethinking how we store and process all this information. The core idea behind Hadoop is actually brilliantly simple. Instead of building one giant monster of a supercomputer that costs a fortune, the thinking was, what if you could just link together hundreds or even thousands of cheap, regular computers and get them to work together as one single, powerful team? This whole idea is called distributed computing. This big book analogy here really nails the genius of how Hadoop works. So imagine you have this enormous book to read. Instead of one person reading the whole thing, the Hadoop Distributed File System, or HDFS, it splits the book into chapters. They call them blocks. Then it hands out those chapters to a bunch of different computers. Then, and this is the magic part, all those computers process their own chapter at the same time. That's MapReduce. And finally, all the individual results are gathered up and combined into one final answer. It's just teamwork on a massive, massive scale. So let's do a quick recap of the key players here. HDFS, that's your distributed storage. MapReduce, that's the brain, the parallel processing engine. The whole show is run by a master computer called the name node. Think of it like the project manager that keeps track of where every single piece of data is. And the worker computers that do all the heavy lifting, those are called data nodes. Now, this whole setup was a game changer, for sure, but it had a huge weakness, a major bottleneck. In the very first version of Hadoop, this one single process called the job tracker was trying to do everything. It was managing all the computer resources and scheduling every single task. If it got overloaded, or worse, if it failed, the entire system would just grind to a halt. So, naturally, that bottleneck had to be fixed, and that led to a huge evolution in the Hadoop world, a new and much smarter architecture called Yarn, which stands for Yet Another Resource Negotiator. And you can see the change right here. It's actually a really clever fix. Yarn split the job tracker's 2 main jobs into 2 separate things. So now you have a global resource manager that only worries about handing out resources like CPU and memory. And then, for every single job you run, a brand new temporary application master gets created to manage just that one job's tasks. It's like firing that one super stressed manager who did everything, and instead hiring a director of operations and giving every single project its own dedicated project manager.
And wow, the impact of this change was just huge. This wasn't a minor tweak. By splitting up resource management from job management, Yarn basically turned Hadoop from a one-trick pony that only did MapReduce into a true multi-purpose data operating system. All of a sudden, different kinds of programs, like Apache Spark for real-time streaming or tools for interactive SQL queries, could all run on the exact same Hadoop cluster using the exact same data.
So, this evolution made Hadoop incredibly powerful. But while it had mastered these huge batch processing jobs, the modern internet was screaming for something else: real-time performance and being on all the time, all over the world. And that need, well, it gave birth to a whole new kind of database. And that brings us to Cassandra.
And look at that. We've come full circle. Remember how we started this talking about Netflix? Well, here we are. Cassandra was originally built at Facebook to run their inbox search, and it's one of the key pieces of tech that lets Netflix handle all its recommendation and viewing data. It's part of this family of databases called NoSQL, which basically means not only SQL, and they're purpose-built for the messy, fast-moving, spread-out data we've been talking about. I love this slide because it just nails Cassandra's whole philosophy. First, it's distributed. Think of it like a library with branches all over the world, so the data is always close to you. Now, this next one is the big one: no single point of failure. Unlike that early version of Hadoop with its one master name node, every server in a Cassandra cluster is equal. It's like a team where everyone has a copy of the plan. If one person calls in sick, the work just keeps going without a hiccup. This leaderless, peer-to-peer system is what makes it so incredibly resilient. So, what's the big takeaway here? What does all this tech jargon actually mean for us? Well, these technologies, from Hadoop all the way to Cassandra, they represent a fundamental shift. They give us what's called horizontal scalability, which just means to get bigger, you just add more cheap servers. No need for a crazy expensive supercomputer. They offer amazing fault tolerance, so a machine or even a few machines can fail and the system just keeps on chugging. And they are built for the global, always-on world we live in, handling the insane velocity and variety of data that defines pretty much everything we do online. So we've gone on this pretty cool journey, right? From the very first systems that figured out how to even handle this much data, all the way to the specialized databases that power the apps we use literally every second. The evolution never stops, which leaves us with this one big thought. If data truly is the new oil, then the race is always on to build the next, more efficient, more powerful refinery. What's that going to look like? That's the question driving the next chapter of Big Data. Thanks for joining me for this one.